Muy buenos días, bienvenidos y bienvenidas al lanzamiento de Campus CTe, organizado por el Centro Tecnológico para la Innovación en la Construcción y la Cámara Chilena de la Construcción. Quisiera presentarme antes que nada. Mi nombre es Yasna Pardo, gerente de Asuntos Corporativos de CTe.
Corporate Affairs of CTe. I'll be accompanying you throughout the day. To begin, I'd like to suggest to click on the language you would like to hear the presentations in, selecting English or Spanish according to the globe on the bottom. We'd like to invite you to share these activities in your social networks with the hashtag Campus CTe. Likewise, you can send us your questions through the WhatsApp number you can find in your Chilean Chamber of Construction screen. We're living through different changes. According to McKinsey, the COVID crisis is accelerating the transformation of the construction sector. Therefore, we need to innovate and look for new alternatives that allow to develop more efficient and sustainable and productive projects. Strengthening the competences of human capitals is key in this transformation process. That is why, with the purpose of contributing to this challenge, we are now launching Campus CTe, an e-learning courses platform, which lets us show collaboratively the different skills of students and technical and professional staff. I'd like to share with you a video that was created for this activity, which included the participation of different and important institutions who are strongly committed with the strengthening human capital and the industry of construction. Please play the video.
La industria de la construcción está viviendo.
The industry of construction is going through a process of change where both technology and the ways of working that are more and more collaboratively have a key role to face the challenges of productivity in our sector. That is why it is crucial to understand that we cannot achieve change without investing in updating of the skills of our labor. Both different academic institutions and companies must focus on the competences and skills and the challenges that lead us to 4.0, and thus allowing professional and technical staff use technology to their favor, changing the way we currently work on to an innovation and ongoing improvement model. We hope we can provide the leaps so we can train specialized human capital. Universities have a key role in this, including capacities of innovation and development and professional training. The 7 universities that make up this consortium are prepared for this change. I think it is a motive of great satisfaction for all of us. The construction sector has a serious problem of productivity, and this is due to the low levels of training there are in the sector, both for workers and professionals. In that regard, the Campus CTe initiative adds itself to a new program we're generating, the Chilean Chamber of Construction, where we want to offer partner companies different methods to generate ongoing education and training in the different fields that will let us progress in productivity, industrialization, digitalization, the incorporation of new technologies, and the construction sector.
El rol de UNECAD como centro tecnológico es la
role as a technological center is a conversion of sciences in technology that is innovative and useful to make companies more competitive through training, specialization training of high technological value aligned with the sector of construction to drive digital transformation and circular economy. To contribute in the challenges that the industry of construction has, In the years to come, CTech puts at the willingness of the sector its a learning platform through the CTech campus. So I'd like to add you, would like to invite you to be a change catalyzer and be part of this.
Ahora, a continuación, les doy la bienvenida a nuestros invitados.
Now I'd like to welcome our guests who will accompany us this morning, Maria Loreto Flores from Zaha Hadid, Chris Carlo from Arab, and Karina Briones from CTech, who will address the importance of collaboration, multidisciplinary collaboration, and the development of new capacities or skills associated to digitalization and construction 4.0.
Bienvenidos y bienvenidas a quienes se están sumando en
Welcome,
los últimos minutos a este canal.
attendees.
Una productividad estancada por más de 3 décadas.
Productive stagnant for more than three decades, low levels of digitalization, high fragmentation of the different stages of the project, low levels of specialization of workers are some of the issues that the industry of construction is facing. It's crucial to understand that change cannot happen without investing in the training of the labor force. According to a recent study published by Macy's and the Chilean Chamber of Construction, only 8% of collaborators of the sector gets trained, well below the more developed countries where this number fluctuates between 13 and 16%. According to this, it is critical for both companies and the study programs or curriculums to focus on develop new skills. To talk about Campus CTech and the role and the training of technological capacities in Construction 4.0, we are going to leave the floor open for Karina Briones, architect from Universidad de Chile, expert in implementation of the BEAM methodology, and currently the executive director of CTech. Go ahead. Floor is yours. Hello, Jazz. Good morning. Good morning to everyone. I'd like to thank everyone that's accompanying us today in this launch of another further action that furthers CTech for the benefit of the entire industry. And maybe many of you don't know us yet and you might be asking yourselves what CTech is. Let me tell you that CTech is a technological center made up thanks to the consortium of 7 universities that are present in Chile and which accompanies us. We have 3 technological centers that are international, such as IRCAT, Spain, and BRE, Tecnalia from Spain, and BRE from the UK. All this under the umbrella and support of the Chilean Economic Development Agency, Corfo, who has given us an instrument, 10-year instrument for the creation of the center. And this year, we're part of the Ministry of Science and Technologies, along with the agency ANIT, who's promoting the research and development in different fields of the national context. This consortium allows us together and with all the capacities that we have with our partner universities and partners internationally, we can provide a service for the construction sector and improve the levels of productivity and sustainability. What does the center aim for? It aims for accompanying companies and institutions of the industry of construction towards the path of digital transformation and to change the culture and the way we were creating our projects before, with the purpose of you being able to improve the sustainability and competitiveness of our projects. Competitiveness that our companies need post COVID-19 when the entire world has changed its way of working. What are the issues of this national industry, not only in Chile, but the issue of productivity in the industry of construction is an issue that many countries face. For example, if we compare the situation of Chile, we realize that in order to generate value or add value in same work, the average of the OECD countries for that same action and work need 6 workers, and we in Chile were able to develop that with 3 workers. This makes our productivity, our indicators, our costs, our overcosts, and our projects to be quite higher. If we wanted to only level ourselves to the level that the OECD countries develop their works, we would be saying that in Chile, we could per year build around 52,000 more housing, benefiting many people a year, 155,000 people a year, or even building 1,500 kilometers of routes to the country. This would bring enormous benefits. And many of the stakeholders gathered today, the Chilean Chamber, CTech, and all the institutions that are part of this consortium, we're asking ourselves, how can we contribute to this challenge? How do we improve productivity and sustainability in the world? In these 4 years that we're already having in their center and in conversation with industry looking at international studies, we've realized that CTech will generate benefits for the sector if we concentrate at least in these 5 pillars. On the one hand, we have digitalization, and for that purpose, we need to elevate the levels of digitalization of our companies. We are the second sector that is the lowest scoring in maturity, digital maturity in Chile, outside construction digitalization that allows to have less impact in situ in the works and having more control of our construction works. We also need to adopt new technologies to improve our constructive or building processes and diminishing that overtime in our projects and overcosts. And all this with an approach focused on sustainability and how we improve the quality and our relationship and impact with the environment. And there's a fifth pillar. All international studies, but even more in Chile, they show that need, the critical need that in order to achieve all of this, we need to get trained, not only in terms of labor, but in terms of the management, professional and technical level. We need to update ourselves constantly in these technologies. Unfortunately, the last studies that the Chilean Chamber of Construction provided a couple of months ago show that at least 68% of engineers or 80% of architects in Chile are not trained at all a year, which means that all of us that already have our bachelor's degrees that are already a part of this sector, we haven't updated our competences, are not updated with the challenges that the industry needs. And what happens with those that are currently studying, undergraduates? We realized that the curriculums, only 2% and 7% of them, of the knowledge and courses are dedicated to innovation and technology, which is quite poor for the challenges we have ahead. That is why CTech is putting at the willingness of the industry different services to start closing these gaps and promote the advance of the industry. On the one hand, we offer advice for companies in adopting new early management technologies like building information management, lean construction, among others. We are constantly providing technological surveillance services, data intelligence, monitoring, follow-up of innovations, and evaluation of prototypes and pilots, exhibition of prototypes and innovations, validations and certification services. But nowadays, we're also launching one of the 6 areas of actions, of all the actions of all these 6 areas to strengthen the capacities of the labor force of our sector. On the one hand, we have constantly developed workshops year after year according to what our customers need. Different international seminars to install in the sector new capacities and knowledge. We constantly create international missions with the help of our partners, but we also visit Chilean companies that are developing innovations that are maybe not that well known around the sector. Number three, we accompany the CCI Council of the Chilean Chamber in leading the Human Capital Committee of CCI for industrial construction. We are developing a rule matrix needed to strengthen industrialized construction in projects, and that's how we can send companies with the skills their work teams need, and we can help them to update the contents of the curriculums of architecture, construction, engineering, all the technical careers of our system. The fourth action we're doing is we're developing courses especially for teachers, teaching for teachers, training teachers to be able to prepare those teachers that have the mission of training the labor force in undergraduate and postgraduate studies and with the capacity of our skills of our international studies. In fifth place, we need to work directly with students in human capital training programs that have real instances where we can learn through labor practices or through the technological innovation park that we're about to inaugurate here outside of Chile in Laguna Karen. It seeks to be a laboratory, scale 1-to-1, where companies, researchers, startups, entrepreneurs have a real scale laboratory where they can pilot and test all these new innovations, new materials, new constructive processes, and so we can all learn from practice our mistakes of about improving disruptive technologies that we can maybe bring and start adopting in our constructive processes. As I commented, we're about to inaugurate this project, and would like to invite you for on April the 28th to accompany us in the virtual and remote inauguration of the Innovation Park here outside of Santiago. This park we did not invent, we did not make up the concept. We worked on it together with our partners from BRE in the UK. Here you can see a photograph in Watford outside of London, where they're testing everything, materials, solutions, even sustainable energy, solar energy, wind energy that's being used to energize this center, recycling of rainfall, etc. What this park seeks to do in Chile is to have this instance of open innovation and collaboration where we can pilot our projects through IT sensors to manage data that we gather from these projects, through artificial intelligence to train everyone, professionals, and to have technological certifications. Well, this is a park for you who will be at the willingness of the industry for us to copy this CChC model that the car industry has, who has adopted many disruptive technologies that allow us through industrialization to free manufacture, improve the quality of our products. We can reduce the waste of our industry and improve the security of all the workers and the production line of a project. Now, this photograph shows the capacities we already have for instrumentalizing projects. The idea is for us to have real constructed projects, but also the virtual uh, twins through BIM models. And together we can apply maybe technologies of high advanced such as IoT, artificial intelligence, and machine learning, and we can create these first digital twins here in Chile, all with your help. The sixth action that's bringing us here with the guests such as Chris and Loreto has to do with the launch of Campus CTe.
Una plataforma abierta de cursos.
We want it to be an open platform of e-learning courses that is 100% online, the asynchronic that you can conduct whenever you want at your own pace, and for everything to be accessible. We are constantly looking at the national market and looking at the contents and capacities that are missing in the labor force. We know that in order to conduct park projects and on the adoption of new technologies in industry, we need to train ourselves. And for that purpose, we have created partnership with Eurecat Spain, this technological center from Catalonia, and we've developed these 3 courses that we found there weren't any courses on digital transformation with a specific lowering to construction and with real cases of the local national industry. That is why we have a first course of introduction to digital transformation, a second course that has to do with the management of change inside companies that can maybe apply methodologies to create all this change within an institution to create a roadmap and also methodologies for diagnosing the levels of maturity of institutions. And a third course, which is quite more technical, that seeks to introduce the concepts of IoT, but also to provide technical knowledge of its application. These 3 courses are currently in our website. So I'd like to invite you to visit the website from CTech, where you'll find the campus website and each one of our courses with more detail and more explained. will have a special promotion or a fee for launching. And during this course, we'll be bidding. We'll have a contest of 10 scholarships, which we will award today or tomorrow in our website.
Presentación, quisiera
To conclude
agradecer
my presentation, I'd like to thank, on the one hand, our international partner, Eurocat. I've seen the potential that strengthening capacities of our labor force in Chile has. They've seen that. I'd like to thank the Chilean Chamber of Construction and Universidad de Chile, who has provided this e-learning platform. I'd like to thank Loreto, Sarah Hadid, Chris from Arab. Everyone together, we're trying to improve our industry. Thank you very much.
Muchas gracias, Carolina.
Thank you, Carolina. Now, I'd like to leave you or extend the invitation to visit us in our website, www.ctechinnovation.cl, where you'll find the first courses available and special discounts for this launch. In addition, I'd like to invite you to share this activity with hashtag Campus CTe and send your questions through the WhatsApp number you can see on your screens. 10 steps for collaborative engineering is the presentation we'll see next by Chris Carroll, the director of UNEDUP. Throughout his career, he has conducted a significant quantity of structural projects that comply with the architect vision and the commercial, environmental, and social objectives as well. He's a member of the World Entrepreneurial System for Development, exploring decarbonization of the constructed environment. Chris, according to your experience, tell us how the modes of working are changing in this more collaborative way between different specialties. The floor is yours.
Okay, thank you very much for inviting me here. I'm going to briefly introduce kind of Arup for people who maybe aren't familiar with who Arup are, briefly introduce myself, and then describe some projects that talk to creative engineering solutions and hopefully advancing the future of our industry. Next slide, please. So Arup we were formed about 75 years ago by Ove Arup, who became Sir Ove Arup, who was a visionary. He was as well as being an engineer and a contractor, he was also a philosopher and had a philosophy education. And he founded the company very much on the principle of total design. From those days, Arup has now grown to be approximately 16,000 employees worldwide. We are in over 30 countries, offices in over 30 countries. And importantly, we're owned by the employees. So we're an employee-owned organization. So all the money that we make, it goes either to the benefit of our employees or is reinvested for the benefit of our firm and the benefit of the clients and collaborators that we work with, invested in research and development, our own internal university, skills development, knowledge, that kind of thing. And very importantly now, at the heart of Arup is the principle that sustainable development is everything. So we've signed up to the UN Sustainability Development Goals and are now applying sustainable principles to all our projects. Next slide, please. So we've developed over those years to work in all aspects of the built environment, but building engineering is still a core aspect of what we do at Arup, and we have a history of creatively working with some of the most renowned architects around the world, innovating and creating kind of new solutions, new ideas to deliver these buildings, deliver this architecture. Next slide, please. now is at the core of what we think about on all our projects. I think there's no question now that there's a climate emergency and we're all facing it, and there needs to be a paradigm shift now in our thinking and the way we approach the work that we do. Sustainable development is everything, and we need to reduce and quickly reverse the damage that we've done over the last few centuries to the planet. And we have to think creatively as to how we do that and how we all contribute to that. We've got to, from a buildings perspective, we've got to drastically reduce our carbon footprint, carbon emissions associated with our projects, and that involves kind of understanding material use, embodied carbon, the carbon that is in the materials that we use to build the buildings, and as well as the carbon that we use burning fossil fuels generally to operate our buildings. And more as our buildings become more and more efficient, the embodied carbon, the carbon in the materials that we construct with, are becoming a bigger and bigger part of that equation, and often are more than half of the carbon footprint of our projects. Globally, buildings account for more than 38% of global emissions through the materials used to build them and the energy used to operate them. So this is a significant contribution that we need to make. And we have to start to think about kind of different ways of doing things. So the concept of circular economy, which is where we keep materials at their highest value for the longest possible time. And we have to start to think about this. So not just using materials, discarding them, throwing them away. We have to think about how we design to keep materials and resources in use kind of in perpetuity. Next slide, please. So I'm a director at Arup, leader of one of the building engineering groups here in London. I've been at Arup since I graduated, so I've been here 30 years, and that's primarily driven by the type of firm we are and the type of projects that we get to do. And that's what's kept me here for so long. I'm a fellow of the Institution of Structural Engineers, and as per the introduction, I also are taking on a bigger sustainability role within Arup, and our partnership director in relation to our membership of the World Business Council for Sustainable Development, which is a members organisation looking at how we decarbonise our building projects. But the core thing I would like to say is although I've been here 30 years, the thing that keeps me here is the projects that we do and the collaborators that we work with, and being able to continue to kind of innovate and create new projects year on year. Next slide, please. So I've been lucky enough to work with a whole raft of architects all around the world, from the bottom left-hand corner here, Seattle Library, to Guangzhou West Tower, many projects with Zaha Hadid. Next slide, please. One of my major projects, and I'll show some other examples, but one key example is and really kind of started me thinking about kind of digital technology, innovation, and how we use that going forward, was this project in Beijing with OMA and Rem Koolhaas, the architects, and it was for a new television center project campus called Central Television, where it was 500,000 square meters of building. Everything you need to produce television all in one building, and to be able to engine it's these two towers of 54 stories high, connected with a 15-story linking piece that cantilevers 60 or 70 meters. And to deliver this building, we had to kind of reimagine what a building was about. So we had to look to use the whole form of the building, all of the geometry of the building, to provide strength and stability and hold the building up. But we also then had to look at using computing power as to how we assessed the way the building was performing in seismic and wind conditions and under its own loading conditions, and then tune that to put the material where it worked at an optimum. And without being able to do that, we wouldn't have been able to deliver this building. Next slide, please. And we had to consider an incredible number of challenges all in this one single project. And this project was only built because of the sophisticated computing simulations that we could do. So as well as working out the stress states and optimizing the material use, we also had to consider things like how the building would be constructed and the stress state as it was built. Next slide. And we had to simulate absolutely everything you could imagine to be able to deliver this project, including the point at which we joined the two towers together, which had to be a particular time of day, because as the sun came up and heated up one tower, it would move away from the other towers. So we had to come up with a simulated construction sequence of joining the two towers together that was optimized according to the time of day and the stress state of the two towers. The analogy was trying to weld together two ocean liners that are bobbing around in the sea. And that was the finished building, an icon on the Beijing skyline. I'm going to reference throughout the next few slides the importance of computing, virtual simulation, parametric design, the use of data. Next slide, please. However, at the start of a project, one of the most important things is to get the fundamental diagram, the fundamental concept right. We must grasp the key engineering principles before we engage the computer, the simulation, etc. We've got to have the fundamentals correct. This is a project with Zahardid's office in Kuala Lumpur. Next slide. And the key thing here was to get that diagram right. So you limit the complexity. So the form looked incredibly complex, but by kind of cleverly thinking out the diagram, we can limit that complexity, understand that complexity, and ultimately simplify that complexity. And on this building, we contained the complexity to the bridging link, and the rest of the tower we were able to deliver in a very kind of traditional Malaysian construction using Malaysian construction techniques. Next slide, please. This is another Zaha project, which I think Loretta will also talk about. It's a science and research center in Saudi Arabia, CAPSARC. And the important thing about the form of this building is it's driven by the concept and a strong concept. And I think this is an important aspect of launching into any project. Next slide, please. This particular project is driven by and the concept of it, the form of it, is driven by the environmental performance of the building. So it's about creating kind of habitable semi-outside spaces that are shaded. It's about channeling wind. It's about collecting direct sunlight on the most effective surfaces. It's about energy efficiency. So all of that is brought together as a concept and then informs the form and the arrangement and the massing of the building. Next slide, please. And as part of the design process, we have to fully understand the geometry that we're dealing with, and importantly, the interrelationship between different aspects of that geometry. This is a bridge we're undertaking with Zaha Hadid's office at the moment. Next slide, please. And the key is a tied arch bridge, and the relationship between the arches, the ties, the cables, the deck alignment, the abutments, the bearings are all fundamental to its performance and efficiency, and need we need to control these parameters from the outset and balance their demands to achieve an optimum result. And here we've used a Grasshopper script, a parametric script that links all of those elements together geometrically. It can then produce a three-dimensional model, which can then be linked to our analysis software, which then can be linked to drawings and more conventional ways of describing the geometry, and all of that is connected into what we call a workflow, and forms a rapid loop whereby we can test lots and lots of design parameters in a very, very short period of time. Next slide, please. And we have to use geometry to deliver value. This is a project with Rem Koolhaas in Berlin that I worked on, and it has a very, very large atrium, glazed atrium, and to put conventional glass systems into that, or to span the 30 meters to form that atrium structure would have been very, very inefficient. So we adopted the form and made a kind of corrugation to the form to reduce the material and make it more efficient. And again, the use of software was important in that kind of optimization, but the key thing was having a good concept and getting the concept right before we started that optimization process. Next slide, please. And how we bring all of this control of geometry and computing power to improve construction quality. We've got to start to look to take as much of the construction process into a more controlled environment. So off-site, basically. Sites are pretty messy, uncontrolled situations, weather conditions, all that kind of stuff. So the more that we can build in controlled environments in factories, the better the quality and the construction process will be. These are two twin residential towers in Stockholm with the architect OMA, tallest buildings in Stockholm at 37 floors, and it's a repetitive kind of pixelated form, which automatically made us think of kind of modular construction at the start. Next, please. So we worked out from the start how to make a structure and a facade from a modular panelized system of precast concrete pieces. The structure, the slabs, the beams, the columns and the walls are all precast, so we avoid any kind of formwork. But importantly also the facade comes as an insulated precast system already glazed, and we worked out the kind of precision of this. Next, please. And this is another aspect of delivering these projects is collaboration. So we there was a collaboration. The contractor SCF Beton and their engineers, we worked very closely with them to work out kind of all the details, review all the details to make sure that they delivered the structural performance, the continuity of the shear walls, and we worked out how all of this could be built as a series of prefabricated pieces, I guess analogous to a Lego set. Here you see the project on site. It was incredibly fast and efficient construction, very few workers on site. This is a working day, and you see there hardly any operatives as the panels come off straight off vehicles and they're assembled on site. They were cycling one floor of construction in less than 5 days, and importantly, that wasn't just the structural frame, but that was a fully insulated and clad shell in 5 days per floor. Next slide, sorry. Sorry, I was talking to that slide. And next, sorry, go back one. So yeah, there you see the construction and how clean the site is. the parts that fit together. Very little kind of site operations at all. Next, please. Now you see the two towers complete. The second tower was even quicker to construct than the first, and the idea that building is a process and not a one-off bespoke activity, I think, is also something that we should consider. So there was a definite efficiency in building the second tower compared to the first tower, as the contractor kind of learned the process and optimized the process. Next slide, please. This is a project in London, Leadenhall, also known familiarly here as the cheese grater, and this was built with the contractor Lang O'Rourke, and their philosophy is based on constructing as much as they possibly can off-site and bringing it in. They have a phrase, no propping, no topping, where they try to kind of modularize everything. In this case, steel and precast concrete, and there was no poured concrete at all over the fourth floor. Next slide, please. And this is a kind of a further example of this. We're also working on the Sagrada Familia refurbishment, and they want to speed up the final construction of the Sagrada Familia. It's in Barcelona. It's taken 100 years to date, and they want to finish it within the next kind of decade or so. And they looked at making it in situ concrete as a way of speeding it up. And we've worked with the stonemasons to work out how you can modularize old traditional construction via using post-tensioned and pre-stressed masonry units that can come onto site as a unitized system, be lifted into place in one action, and then grouted together. Next slide, please. And I guess the modular building to its full extent would be volumetric modules. And this is a project in New York, which was for a time the tallest volumetric modular building in the world. And these modules are fully fitted out in a factory, brought to site, and installed. Next, please. So this is the blocks building in Copenhagen, with the client Real Dania, and it's an interesting project in terms of how we think about the building grid, which is usually an arrangement of orthogonal frames made from beams, slabs, and columns. But this was a key in a city site that had been undeveloped for 60 years, as it was too complex a site. Next slide, please. And it had many planning constraints. Being in the historic part of Copenhagen, but we had to deal with the fact that the building went underneath the ring road, over the ring road, cantilevered over the dock. As a planning requirement, had to have a 350 car parking spaces, which meant that it had to have an automatic car parking system, and all of this led to very limited number of places where we could put columns and a high level of complexity. Next slide, please. So again, we need to start with a basic diagram concept and get that right. So simplify the complex and reimagine the grid. Next slide, please. And we did that in this condition by coming up with the idea of these 18 trusses that were story high, that occupy the building but create a framework that the rest of the building can be constructed in a way that uses conventional construction techniques. So these 18 trusses that you see here allowed for the rest of the construction to be vernacular, to be adopt what the contractors were used to delivering. Next slide, please. But to realize that, we had to again use the full extent of the technology available to us, and we had to think of everything again. So simulate how you would construct the trusses virtually, so we could assess the stresses that are locked into them, the construction sequence, work through that with the contractor. Next slide, please. We had to work with the facade contractor and we had to write some specific bespoke software here, script that plotted and visually plotted all of the relative deflections at all of the gasket points, otherwise under all of the different various load combinations. Otherwise, the very large kind of 4.5 meter high, 3 meter wide panels of glass wouldn't have fitted onto the building. So we had to adapt kind of our process and write specific software for this project. Next slide, please. And consider everything. So how the fit up of all of these kind of complex load paths worked, how the tolerances were managed. All of that had to be done via virtual simulation of the actual conditions. Next, please. And again, thinking holistically. So as part of that concept, figuring out how the environmental aspects of the building would work, how it would be a low energy building, how it would kind of utilize the materials, daylighting, as much free cooling from the district system as it could. Next slide, please. And the only way to realize this level of complexity what was to BIM and a virtual twin of the building. So we model every single pipe, cable, wire, and their interaction, but also their interaction. Next slide, please. Their interaction with the structure, and next slide again, and how that all comes together in the building form. Next slide, please. There you see the building in its finished state a year or so ago. Next slide, please. This is the last project I'll show, but I show this because of the growing importance of kind of technology and a higher level of technology in the built environment. So this is 181 Fremont in San Francisco, a high-rise office tower, 800 feet tall. Next slide, please. And to realize this tower without in an efficient way that saved thousands of tons of steel, we looked to employ damping technology and looked to use energy absorption and performance-based design rather than prescriptive code design, and engineered the building from first principles. Next slide. Adopting the kind of principles of a car suspension system in relation to how we would absorb the energy from major earthquakes. Next slide. And that's the dampers in position. Next slide. And we also employed one of the reasons in Kyoto, if anybody's familiar with it in Japan, there's 1,000-year-old pagodas, and the reason they survive is they rock on their foundations and they lift up. So it's also thinking about how you can deploy that ancient technology on a modern project. So here this building is designed to lift in its corners, but lift in a controlled way, and that again absorbs a significant amount of earthquake energy. Next slide, please. And then you see the bearing at the base of that column. Next slide. And all of this is only possible because of the way we can simulate and simulate in an accurate, non-linear way the way these materials and devices work in major events, earthquakes, etc. Next slide, please. And finally, everything I showed was steel and concrete. Steel and concrete is, in the world today. I read we build a city the size of Paris every week globally, and the predominant materials are still steel and concrete, but maybe we have to start looking to use much larger quantities of other materials, maybe timber. So this is a project in Cambodia that we're doing with Zaha Hadid, where we're looking at making a kind of bespoke timber frame. The bottom right hand corner is a project we've done here for Sky, the television broadcasters, where we created their headquarters in a year using timber frame. Next slide, please. But it needs to be used intelligently. It shouldn't be a gimmick, and it shouldn't be used unintelligently. So timber used badly can be worse than using steel and concrete. And also timber, if you don't consider what happens at the end of its life, if it's put in a landfill, gives off methane. If it's burned, you have to think about the full life, the whole life. So we have to be using new materials in an intelligent way, not in a gimmicky way, and we probably have to use them compositely with a selection of other materials. Last slide, please. So I'd leave you with these takeaway points maybe, and you can make your own conclusions. But from our perspective, sustainable development is now everything, given where we are in the world. I embrace the full potential of the digital era, but don't forget the clear diagram. Don't forget the principles, the fundamentals of what you're trying to do. Keep exploring and enjoy it. Enjoy the process. Thank you very much.
Muchas gracias, Chris, por tu interesante presentación.
Thank you very much, Chris, for your interesting presentation.
Thank you.
And for showing all these projects that you develop globally in Europe.
Thank you.
Esta actividad en
We'd like to invite you to share this activity in your social network with the hashtag Campus CTe and send us your questions that you'd like to ask to Chris or Carolina, and then when we see Loreto's presentation. So you have that WhatsApp number on your screens. And that's how we will receive all your questions. Now I'd like to leave with you Maria Loreto Flores, Chilean architect and senior associate in Zaha Hadid in London, one of the architecture offices more well-known globally and pioneer in the development of complex geometries and digital design with more than 15 years of experience. Loreto has led multidisciplinary teams in Europe, in Middle East, in Latin America, and in Asia. Her role is currently focused on large-scale project management and in mixed-use districts with 1 million square meters constructed. She will now talk about capacities for digital and collaborative design, and would like, Loreto, for you to share with us what type of innovation and new technologies you're incorporating in your projects. Go ahead.
Loreto, no te escuchamos correctamente.
Loreto, I think you are muted. If you can check. Okay. Well, you already introduced me. I'd like to thank Carolina, CTech, for the invitation to be part of this event and for the opportunity of sharing our work with all of you today. Beyond showing the projects which I believe most of you have seen published in different media, for us it is interesting to show our design process and for you to see the importance and the advantage in the use of digital media, of new technologies for the development of these projects and how they contribute to enriching our own work. This is a brief introduction as Chris made. In case there are people that don't know our work that well and how much we've been working on the discipline. So Zaha Hadid Architects was founded in London by Zaha Hadid in 1979. And since that time, we've been at the avant-garde of digital architecture design. We're globally known because of the innovation that we include in each one of projects, because of exploration in complex geometries and the the representation of these, and in the last years, the way in which we've conducted these and how we built these buildings. Our portfolio has more than 61 projects built in 18 different countries during these 40 years. We work at all scales, from products to installations to inside architecture, housing, infrastructure projects, transport, and also master plans. This leads us to being a team that is highly trained to assume different typologies. We do not concentrate in just one. We also work with customers that are of the private and public sector. In terms of our services, we conduct master plans, interior design, architecture, products, displays. We work with BIM. We have BIM platforms inside our offices. And we also work with workspace analysis in the case of the design of workplaces, of course. And so we have a team dedicated to research in computational design, parametric design, virtual reality, and as Chris was mentioning before, sustainability is one of the important issues that we're trying to include in all of our projects from early times, since the generation and the concept of ideas. We have a global presence. Our headquarters are in London, but we have satellite offices in Beijing, Hong Kong, Dubai, New York, and the city of Mexico. And we're currently developing more than 38 projects in 24 different countries in different stages of the design. One of them are in the stage of concept after being awarded a tender, and others are in the construction process or stage. In order to talk about capacities, in order to include technologies, in order to include digital media, I believe that one of the most important things we must do and or have is collaboration. And collaboration is directly related with the culture of working, with sharing knowledge, and with the work methodology, with the way in which we use our tools, not only as technical tools, but as tools for design. We are a multicultural team. We currently have more than 450 architects distributed in the office headquarters and satellite offices, more than 55 nationalities and 45 different languages spoken, which enriches much the way we work on and the places we can work in. In terms of our organization, after our founder Zaha Hadid passed away, Patrick Schumacher, the collaborator for more than 3 years, assumed as the head of the office, with a board that includes a CEO and 3 directors that are responsible for the work groups, the macro work groups inside the office. As you can see, we're called clusters. We're divided in different clusters, and the main clusters that appear at the center of the diagram are clusters that work with projects from the beginning of concepts, the initiation of concepts to the construction, and we're constantly being fed back by other clusters and research groups that are specialized in these areas. For example, we have a cluster that is specialized in design, which is a Zaha cluster, and this cluster has as its general aim, as an aim to generate ideas that are later tested, mainly in tenders, and when those are awarded, of course, we start developing the project in the other stages. And there's other teams that continue with the provision of the project regarding the construction. Then, to the left of the screen, you can see the specialized groups. We have specialized in different disciplines. We have Code, our research group applied to design. They work with innovation in materials, new constructive capacities. They have academic training, which is quite strong and links with the educational institutions, which allows us to be at the avant-garde of new technologies and how disciplines are advancing. We have a BIM group which also feeds back all these projects. We have around 30 to 35% of the projects that are being delivered in BIM. I'll explain later how we work with them because our approach, since it is from the point of view of design, we need to use the tools in the different stages according to how they relate with the geometries we're working with. The job request. We have the workplace strategy team, which works with workspaces. There are consultants from the development of offices, and we have the virtual reality area, which allows us to have visual presentations where customers can walk inside the projects we're showing, and of course the sustainability group who is helping us to integrate sustainable ideas from early works of the project. The right hand side, I have Sahahadi Design, which is the group that works mainly in minor scale projects, exhibitions, products, and who is responsible for our gallery and showroom we have in London. I thought it was worth noting that, well, where we work, where what our workplace is. I wanted to show it because it has is directly related with our work culture and how it strengthens her horizontal line and how we convey knowledge. This is in Bowling Green Lane in Clerkenwell in London. It is a school, ancient school, and all interior spaces are these large spaces where teams are sitting down very close by with a board and with the heads of project, which allows the design decisions be quite democratic and quite participatory. We now have
básico, pero me pareció interesante mostrarles que trabajamos con distintas herramientas digitales, como decía, en distintas etapas de proyecto y de acuerdo a lo que queremos lograr.
and according to what we want to achieve. We use this correctly and incorrectly. We have trial and error, but I believe it's one of the most interesting things because it lets us test softwares and many of the companies that create software, such as Mailgun, Autodesk. They ask from us, and many times we do tests or to new tools, or that we propose new tools they can include according to our flow of work. So I've separated in 4 stages the design process. As I mentioned, this is something that is quite simple, but I think it gives you a general idea. We have a stage concept, detail design also, which is highly technical, and we have construction and manufacturing later. In terms of the concept, we work with schemes. It's we try to find the way proper to the site and proper to the where we're working. We generally use Maya, which is an animation software that lets us work with these geometries that are not possible in the other platforms that are a bit more rigid. Nevertheless, the use of this tool can only lead to one part or stage of the project, because in the next one we need to rationalize it and to be able to provide information to consultants, engineers, or constructors.
Vienen, digamos, bastante temprano en el proceso de diseño. Después tenemos
If they're early in the design process, then we have the use of Rhino, which is very common, which can be used in terms of concept. We mainly use this in the central stage of the creative process when we're creating the form, which will be the final form, and where details start appearing, we need a higher level of a definition. In some cases, Rhino also helps to provide information to the constructors and others. In terms of Grasshopper, it is a parametric tool which has allowed us to use this in the design process when,
mostró anteriormente y que les voy a explicar luego.
as Chris mentioned, when we're looking for the design to respond to the environment and environmental conditions in terms of sun, in terms of predominant winds, etc., and when facades have to fit to this information. However, we use this a bit more in the core process when the details of the project are being defined, and many times it is the final tool that allows us to show the information to the constructors. This has been for the modeling and coordination and documentation. There's many projects that the contract or agreement says that in addition to drawings, we give a Reddit model. And in this case, it is a tool that is used when the geometry is defined and confirmed. That's in practical terms, because there's much geometry that is quite complex to go into Reddit. And we've created some examples, and I believe we'll progress. And it's part of what the tool is enriching. When we create our own tools or definitions, many times we will provide them to the software for them to be included and for other people to use them. In terms of external collaboration, and this is quite interesting in terms of Chile, because I hope we can do projects soon there. There's always a division of work between what we do, and we'll start building in different parts of the globe. So in general terms, the conceptual part is in our hands, and the local architect and local consultant provide us information related with the site, with the place, with the regulation. But when the project is in the design stage or construction stage, of course, our local partners are the ones that require more responsibility in terms of the project. In terms of organization and how we work with the different projects, there's different modalities, but what we generally use is that after the customer and the manager of this type of customer were hired as a lead consultant, and under our guidance, the rest of the consultants could be structural engineers, facade, illumination engineers, cost consultants, landscape artists, and the local architect. But that depends on the type of project and type of relationship the customer wants to include. In terms of global collaboration, this is one of the figures that we're looking at lately in projects. This is the case of Morpheus, a project which I worked in since the beginning of this construction. It was a global collaboration with teams in different time zones. We held meetings one time a week remotely. There was part of the team that was in Los Angeles, the other part in Europe, in London, Belgium, and all the constructors and manufacturers were in Asia and China, which helped much in terms of mobilization and the precast of manufacturing of projects. In terms of innovation, the other component of these capacities needed for using digital media. What is the advantage of using digital tools? One of them is optimization in our case of complex geometries. The use of digital media has made possible that our design, the geometries that we're proposing that are not traditional, can be constructed, and the automation of processes that would mean a reduction of time, resources, and costs, and sustainability, which we'll see later with two projects at the end of the presentation.
En esta
In this image, I'm showing the definition of the Morpheus project. It's a structural exoskeleton, steel. When we saw the challenge of building this building, there was two options. One, there was to do the manual modeling, which took from 25 to 30 days for 2 or 3 people. And the other way was to try to produce a parametric tool that allowed us to reduce time and also be able of exchanging this information with the rest of the design team. This is an accelerated demonstration of what this digital tool did. This image illustrates the way in which we work and what we seek to achieve and how digital tools used in an intelligent and strategic manner. In part of the design we need to do, how this allows us to reach the final result and also lets us collaborate the best way possible with the rest of the consultant. Another example of this is the Heydar Aliyev Center in Azerbaijan. It is one of the most emblematic projects of Saha, and it is, of course, the one with more challenges in terms of geometry. There's a rationalization process, of course, in which the use of digital tools was critical for exteriors and interiors in terms of the panelization of facade, the design of the auditorium, which is completely in timber.
Después tenemos otro ejemplo que es uno de los primeros proyectos que se realizó completamente en BIM, que es el Galaxy Soho. Es un edificio de uso mixto en el centro de Beijing.
Mixed use in the Beijing center. This building, as I mentioned, and relating it with the prior diagram of the work methodology, was modeled mainly in grid, which allows us to work with ways that are softer and generate the reference surface or the inclusion of the design. Then this concept model is taken to a arena model where it is possible to extract the slabs, the facade contours, and start understanding how we can build this building. The next stage was the construction of the BIM model, and then the coordination and provision of full documentation of this project, which was mainly done in CATIA and Digital Project. Another important component is the mock-ups for conducting the facade of Soka China. It was very important to understand what the most proper material was for facades, which were the local capacities of constructors or manufacturers in this case, how much time that would take, and how could we as designers rationalize the facade so we could reduce costs. There were 4 or 5 stages where we took the model and we streamlined, rationalized the panels, which was double curvature in the beginning, and then we reached a percentage of 90% simple curve panels, some areas, and just the areas of bridges and connections between models, we use double curvature. This is directly linked with working with the manufacturers, and that's the importance of the role of digital media, and of course of creating these mock-ups and reaching the result we wanted as designers and the customers wanted as well. Here we have the final result again, and a view of the interior yard created by these 4 interconnected volumes. Another very good example, and I believe one of the most wholesome examples we have in our office or integrals we have is the King Abdullah Petroleum Studies and Research Center that Chris mentioned, the project that was done in collaboration with Arab. First of all, the automation of the project, the use of BIM, and how the design responded integrally to conditions from the environment. So in this case, we're not saying that the sustainable issue is measures that were applied at the end of the project, but
Geometría fue cambiando en los
it was how geometry was changing in the different stages of the project to respond better to the requirements.
Tenemos otra vez, perdón, el mismo proceso modelado primero en Maya.
We have the same process again, grid, and then rationalization. This is a sketch of one of the meetings where we worked with engineers and we decided what the best requirements and changes are that we need to do. And then we need to go back to the virtual platform to do the changes. Finally, we need to create a model that integrates the structure of cells, but installations also to understand the intersections and the areas we need to improve in. I haven't spoken of what each project is from the point of view of the program, because I believe it's more interesting to focus on how things are done and to show what we generally do not see, which is how we work and how each stage requires much thinking, rationalization, and innovation. New ideas, trying to see how we can respond to challenges and which tools we need. In this case, we're showing how each cell of this project, which are different workshops and centers, research centers, responded to the predominant winds, the orientation, and how we calculated the openness of the facade to have natural lighting, but also thermal gain that is proper, and the generation of these interior yards that generate shadows or have shadows at some time of the day, which makes it quite comfortable to be outside in extreme climate. Mock-ups are very important. The comparison between what we want, what we call the design intent, and how we conduct this in reality, working with the manufacturer's information they receive from us to do it as per what we imagined, as per what we showed to our customers. In this case, facade studies were very important to understand if what we proposed from the point of view of design was truly working or not in terms of the sun we needed. This is the final image of the entire building complex. Morpheus City of Dreams, as I mentioned, is the project with which I initiated the second part of the presentation. The most interesting part of this project is that it was a fully collaborative project. We created a digital platform where we as designers and engineers and manufacturers of the different components of the facade were able to share the model and update it every time we had meetings. We provided certain reference models that each one of the different stakeholders could use to start manufacturing the part they had to. We have the flow of work, which was agreed quite early in the project stage.
Esquemático y tuvimos participación del constructor también desde el
And we also
principio.
had participation of the constructor from the beginning. Therefore, the design was directly directed to how it's going to be built. This is the final image. Morpheus is a 5-star hotel, which is in Macau, which has 800 rooms distributed in these 2 towers, connected with this intermediate spaces, and the entire building is structurally supported by this external skeleton and the internal cores. The quantity of elements that were precasted or pre-manufactured in Shenzhen, China, were very important. They were made in China and transported. We can see images of the work, images of where they had the curve lining of the structure where they built and the macro windows. We see how these pieces reached the works and the installation of the curve area of the exoskeleton and inside the building. This is the final result. Parametric operations were also used for the design of interiors. In this case, the main atrium of the building, which is a 40-meter high space, free with no columns, flanked by these 2 internal facades that were also designed by us, by our office, and the other 2 extremes where we have the panoramic elevators that lets us travel through the entire building, and we can see the situation inside and outside when we're processing the empties. There's 2 projects that are important in terms of sustainability. They're both related with sports events. The London Aquatic Center is a great example, also collaboration with Arab. 2 ideas from the perspective of sustainability is the reuse of the same building with 2 different modalities. In the top image, we see how it was designed, conceived for the Olympic mode, which with 7,500 people capacity and how the wings that provided this capacity were removed and they were left with legacy mode, and it's one of the sports centers that's most used in the east of London. It was a second sustainable intention. We had innovation in the use of concrete. I think that Chris can give us more detail. We call it the green standard concrete. It is a concrete that included a large percentage of aggregates that came from recycled materials that let us reduce the carbon footprint of the building. We also reuse many of the materials that were removed from the area in which the building was built in other parts of the Olympic Park. Finally, this is a project that is not built yet, but we hope we can continue working on it in the office. We had the building permit, obtained it not so long ago. It's the four-screen Rover Eco Stadium, a stadium that is completely conceived in timber. It is part of a park, ecological park outside of the city of Strutt. It was designed parametrically, mainly in a stadium, because every time the dimensions of the structure should be modified and modify the angles. So the parametric tool is very useful to obtain fast results. And we hope research that lets us use timber and structure and in the interiors can be exhibited in the next years to come as one of the first projects that were parametrically developed with a great sustainable imprint. Thank you. This is my last slide. Thank you, Loreto. Very interesting presentation. Spectacular project you're developing. Thank you very much to all the presenters, Carolina, Chris. Now we have a brief space for a conversation based on one of the questions we got on WhatsApp. The idea is for all three of us to respond to the answer. Which new capacities do you think that labor forces need to introduce these new disruptive concepts we've seen in your presentations and the new ways of working that you showed us today?
¿Quién inicia? ¿Loreto? ¿Chris?
Who wants to start? Chris? Loreto?
I don't mind starting if you like. I think one of them is the continuation of looking at construction as a kind of manufacturing process. Historically, we've built buildings as the mass of buildings we've built as discrete projects, as bespoke projects, and we use materials and certain techniques, but we don't gain anything from systemizing the process. And we also, if we can take more of the construction process into a much more controlled environment, we can gain again in that kind of process, but we can also gain in terms of quality, efficiency, the resource we use. I mean, if we look at other manufacturing industries as kind of references as to what the future might hold, you can really optimize a building. And in terms of sustainability, one of the biggest gains for us in the short term is just to use less material. We generally use about 50%, 100% more material than we need to if we were to position all of that material in the right place and consider our designs as from a performance basis rather than a very prescriptive code basis. So I would say some of those things are the direction in which the general construction industry should be looking to move in.
Thank you, Chris. Loreto, en tu opinión, ¿cuáles son esas capacidades que requiere hoy
Loreto,
en día
what's your opinion on this matter?
enfrentar estos desafíos?
Creo que hay tres ideas, lo quiero resumir en
I think there's 3 ideas. One
el mindset. Creo que es muy
is the mindset. I think that it's very important to have an open mindset to wanting to implement technologies and being convinced that's one of the best ways to proceed. And I think it's something that has to come from governments. And in Chile, I think we're doing this with the implementation of BIM, with the work that you're doing in CTech. And I think it's important that more people are aware that if we don't have clarity that the use of technological media are helping us to enrich projects and make them much more sustainable, it's not possible to advance. The second place, we have the skill sets. Mindset, skill set, and of course that is training of professionals to do these challenges, to try to learn, to maintain updated in the new technologies, to learn from examples, external examples. And in the last place, we have the tool set, which are the softwares and the tools, which I believe for many companies, it's hard to step there because it is an investment that is done without knowing how it'll work out. It takes some time, but given the experience we've seen in the work with some constructors, it is an added value. It allows them not only to work with architecture companies, but to broaden perspective to other disciplines and to obtain from them other tools that allow further enriching the processes.
Muchas gracias, Loreto.
Thank you, Loreto. Carolina?
Sí, ya está. Primero que nada, agradecer a nuestros invitados.
First of all, I'd like to thank our guests. Given the time, we won't be able to have more spaces for questions, but I'd like to tell Chris and Loreto that the truth is that we know in Chile we're a bit delayed in terms of innovation and technology, but based on what you showed us today, it's not that we're delayed, it's that we're late years away. It is quite noticeable all the technology you use. But mainly what you've told us, the methods of rationalizing, of thinking about a project. Realize that projects would not be able to be conducted if we didn't have that collaboration. And through your projects, we realize that that collaboration starts from early stages. In Chile, the few projects that are using certain technologies, industrialization, when it is designed, we start sitting down and saying, oh, okay, what can we industrialize? What can we pre-manufacture, precast? And I believe that we're going quite late into the process. And in Chile, within my peers and colleagues, there's still that conception that implementing software and technologies such as BIM will limit their fluidity and freedom in designing. And I think that through projects like Loreto and SAR, what they show us is, on the contrary, this technology is what they do is to support and give even more argument of why it is good to rationalize and to know that there's some freedom in design geometry, but we want to rationalize it. As Chris showed from the beginning, we started knowing the diagram projects that were very simple that show us how we work on structural behavior and all that, holistic vision, sustainability, and the carbon footprint. So working on many challenges at once, and we realized that there's much we must learn from the customers that request the projects, from public and academic institutions, and all of us are engineers, architects, consultants that are developing these projects. To close, I'd like to seize this opportunity to invite Arut through Chris and Saha through Loreto for us to convey those capacities. As Loreto mentioned, we need to change our mindset and these methodologies of working, the skill sets, and for us to learn to use these tools, maybe not to develop avant-garde designs as you create there, Loreto, but yes, because we do need to improve our processes in Chile to have a perspective from the environment and to improve the quality of our buildings. So you're now committed because we need to have these capacities in our innovations park, which is inaugurated at the end of April. And would like to invite all the companies and all institutions here to collaborate in this and to build it together. Okay, so thank you very much, all speakers. Carolina, Loreto, Chris, quite interesting conversation. We have some findings. It has to do with improving human capital in the sector, the mindset, skill set, the use of tools, new technologies, for more efficient use of materials, as Chris mentioned, and caring for the environment. Before concluding, I'd like to mention that our website, in our website, we'll have the 10 winners of the free course that we've selected randomly. So we have concluded with the launch of Campus CTe, and would like to leave you very invited to go into our website and know about all the courses we have available. During March, we'll have special discounts with the promotional code Campus CTe. I'd like to thank all of you for participating. Members of the panel, thank you, Chilean Chamber of Construction, for being a partner in this event. And you can just go into our YouTube channel to look at this video again and to the Chilean Chamber of Construction website. You're very invited to the launch of the park on April the 28th. So thank you very much and have a good day.
Hi, Loreto, Chris, thank you very much. It was wonderful, your presentation. Really, really incredible.
Thank you, Loreto. Thank you, Chris.
Okay.
Creo que me pasé del tiempo, ¿no? No.
Yeah, my
I think I
pleasure.
went beyond my time.
Teníamos 10 minutos de holgura, en realidad.
Yeah. Yeah, hopefully we didn't run over too much.
But we didn't want to stop because the presentation